Okay, so this is my wrap-up video for the Pololu generator genset, I guess you could call it. I got everything working. Seems to work exactly the way I want it to work. This is kind of a proof of concept video. I don't think very many people have done this or something like this. If they have, I can't find any information on it. I've seen people who look like they started working on something like this, but if they ever finished it, they never reported on it. So what we're going to do is go over the control box, which you'd have to watch the previous build on this to really know about the inner workings of it. But basically, let's try this again. Basically, we have an input for the generator. We have a connection for a 12-volt battery. We have the start button, a load ready indicator, load switch, 10 amp fuse for the system. We have a cigarette lighter type outlet, and we have a 13.8 volt. I'm sorry, these are just terminals like you'd find on an old oscilloscope or some older power supplies and such. We have the USB port for programming the Pololu. We have a input. This is for air to come in. We have an exhaust fan. We have the output for the servo. Just have a couple of pads on the bottom to hold it off the ground. And I mean, that's basically it. And as an overview, I'll just quickly show you that we'll plug in the 12-volt battery. And then to simulate a load, which I can't hit the start button because I don't want to try to put 12 volts into the... I will hook up this 18 or 20 volt battery. And then for our servo, I just have a random servo that I use for testing. And so the 12 volt battery provides power for the Pololu through a buck converter. It takes in 13.8 volts and bumps that down to 5 volts, and that powers the servo and the Pololu. So if we turn on the load, you can see that we've got 20 volts coming in and about half an amp, because that is actually charging the battery, or maybe charging the battery. And if we turn on the governor, it should, oh that's right, it's because it's we're showing 20 volts, it's not going to move. So let me take off our 20 volts from the load, and okay, I had to restart everything. Something happened when I was doing my printout of the source code for this, and I think something got changed that screwed up the script that was on this thing. So I have the correct script on it now, and right now it's got no load and it's reset, so the servo is not moving. And since there's no voltage, if I engage this, it'll start moving the servo because it's trying to ramp up the voltage. And so you can see that's moving a little bit. If I turn on the voltage, it'll stop. Turn it off, and it moves. And if I hit reset, it goes back to 0, which is an arbitrary position on this servo. Any other servo, you'd have to figure that out. Basically, what I had to do with this is I had to hook the servo, once it was mounted on my board and was connected to the carburetor to the throttle, I had that connected by a length of stiff wire, and I had to adjust the tension on it, and then basically I moved a slider back and forth and observed that when it was at its neutral position or idle, and then how far I could move it, and how far it would increase the throttle. And the throttle could be increased quite a ways on this thing, but I wanted to limit it. And so once I figured out what those ranges were, then I just programmed that in as a limit to this. This helped in the source code because it was easier to set a limit than it was to program limiting information in the program itself. And the other thing I did, like I said in the previous video, is that I set the throttle a little bit higher to get this voltage up above 15 volts, so that when this starts ramping it up, it doesn't have as far to go. And also I limited the maximum throttle. I'll show that here in a little bit. But yeah, this is the basic gist of it. This doesn't move because there's a voltage, but if I take the voltage away, you see it starts to move. And since the voltage isn't higher than 25 volts, this will stay where it is. That's the key thing about this, is once it gets to a voltage, it's supposed to just stay. And then when you're done and you're ready to shut down, you hit the reset, turn off your load, and you're set. So the next thing I'm going to do is, oh wait, this has to stay connected. And what I'm going to do is I have to switch over to the screen, and to do that we're going to I need to sync everything up, so we're going to do that here right now. And so what you're seeing here is when you connect to the Pololu, it's set up to run the scripted startup. So as soon as power is applied to this thing, it turns on, and it just starts trying to work. And so it's important that the reset switch is in the reset position, and you can possibly see the red marker as it steps through the program. And then over here we have the stack and the information that's on the stack. So I'm going to turn on the switch, and you should see the information on the stack change. Let's see. Oh, that's right. We got to have power. Come on. All right. So, I don't know if you can see this stuff, but I will turn the switch on again, and you'll see that it starts trying to climb up the throttle, and I'll turn it off, and it resets. And I'm going to stop the script now, and we're going to go to the status. And this is the actual status of the different devices attached. If I hit the switch, you'll see that it's marked as voltage. It's on pins 5, or it's device 5. Sorry, it's it's volt 2. And this is on, even though it's gone down to 0, and this is off when it's 255. The programming for this is kind of weird. So when you program for this, on is not 255, on is 500. Apparently the switch has a maximum. It's supposed to be between 0 and 1,000, but it'll never get up that high or something. I don't know. In the program, it's just, is it greater than 500? And I'm going to run the program, and we'll go back in here. And you can see that with the switch on, it starts moving the servo through its maximum travel. It's going to keep trying to move it in little increments until it gets to the top, until I turn the switch off. And then this one is the voltage, and when I turn the load on, you see it jumps up, and the voltage, even though it shows 0 to 255, the number that the machine, that the Pololu gets, is actually between 0 and 1023. So you have to do some multiplication for these. And the same with the throttle position. It's actually this number times 4. It's kind of weird and not intuitive. But as you can see the program working. The other thing you do is, here is where, let me stop the script. This is where you set what each channel does. And you can see we've got the label for 5 is voltage. It's an input, and you can't change any settings for it because you can't change settings for inputs. 2 is a switch, it's an input. 0 is the throttle, it's a servo, and I have set the min as 2000 and the max at 2200. Now the program changes that to 2240, and I'm not sure why. I think it has to do with the actual position of the sensor or the servo. I didn't mess with anything other than I changed the acceleration to 20. I don't know if it had much of an effect on the actual program. 8-bit neutral, I believe, is the center position of the servo, and 8-bit range. I don't know. I didn't mess with either of these. Serial settings, I didn't mess with those, and I haven't done anything with a sequence. It's just this simple script. So I think that's the gist of this. I'm going to reprint out the script because I think the one that I've printed has got an error, and then we'll come back to this. Okay, so let's zoom in as much as we can here, or much as is reasonable. And I'm going to go through this script as much as I understand it. And there's probably tons of errors in here, and there's ways it could have been done better and all that kind of stuff, and I don't really care. It works. First line puts 100, just the 100 on the stack. It doesn't really do anything. It's a leftover from something else I was doing, but I didn't want to mess with the program, so I left it in. Top, that's a marker for a location. 8800 0 servo. What that does is it tells the servo on connection 0 to move to 8800. This is where I figured is the idle position for my servo. Yours may be different. Begin and repeat. This is the actual program here. This is the main part. Everything really cycles between here. Button. Button is a subroutine. And basically it's kind of like it's saying run button. And button just moves down here to the subroutine button, and it says to get position of device 2, and if it's less than 500, return a true or 1, and then go back. So if our button is not on, meaning it is if it's not on, it will go here to else, off, keep checking for on, and reset the servo. If it was moved, go to top. So basically, if the button is off, it just keeps setting the servo to 8800, which the servo's at 8800, so it just stays where it is. Okay, so if we do button and it's on, then if on, proceed with program. Everything with the pound sign, that's a remark. The program doesn't see it. So really this command is just if. And what is if? It means, is it true? And so you could actually put if up here next to button. So is the button on? If it is, proceed with program. So the button is on. First thing we want to do is see, is the voltage too low? And so this subroutine is called too low. And that's right here. So 5 is the device that is hooked up to my voltage sense, and it will get the position of 5. And if it is less than 750, which is approximately 15 volts or thereabouts, it doesn't really matter as long as it's higher than the idle speed. So 5, get position 750 less than. So is the position of input 5 less than 750? If it is, get the position of the servo 0, which is at 8800, minus 10. Now I've been told that this is backwards and it should be 10 minus, but whenever I've changed it, the program doesn't work, even if I remove this negate statement. We'll get to that in a little bit. So basically it's going to take 8800 and it's going to take 10 off of it. So it'll now be 8790, but it'll be a negative number. Then it issues this command over, and I'm not sure how this helps, but apparently it has to be there, and you'd have to look up what over does in the Pololu script language. Negate. Now that means turn the negative 8790 to a positive, because it's a negative number. Negate turns it positive. If it was a positive number, it would turn it negative. So now we've got 8790 and 0 servo. What that means is just take the servo at 0 and move it to the number on the stack, which is 8790. So it will then move the servo a tiny little bit, and it'll wait 10 milliseconds. I've tried removing these delays, and it could be you could do this with a get is in motion, or whatever the command is, to check if the servo's moving. Or I don't even know if it has anything to do with it, but if I don't have these delays, the servo has a tendency to just race all the way up to as high as it can go quickly. Alright, so is it less than 750? It is. Take off 10, skip this else, and then endif. So we're going to go from the 10 delay, we're going to skip down. We're going to skip down from here to endif. We're going to swap the numbers on the stack, and we're going to drop the most recent one. Now once again, I'm not sure. I put these in here, the swap one. I know what the drop one does, but swap, I don't know why I need to do that, but the program doesn't work right without it. Skip is another marker. Return. So we're going to go back up here to right after too low. We're going to wait 100 milliseconds. This also seems to have to be here. Without it, the servo just races one way or another. Now we're going to check, is it too high? So we're going to go down to too high, and too high is kind of the opposite of too low. We're going to get the position of servo on 5. Is it greater than 900? And if it is, we're going to do this line. But in this case, because we're still between, we may be below 750, it's going to skip all this, and it's going to go to else, go to skip 2, it's going to drop out of the subroutine and return. It's going to come up here, going to go to the endif, and it's going to repeat. So it's going to go back to here, and basically it's going to just keep doing the too low subroutine until the voltage is at least above 750. Now let's say it's overshot, which it does do that. So we've run through this this subroutine a whole bunch of times of checking the voltage. Is it too low? Is it too high? And now we're above 750. In fact, we're probably at 910. So too high, we run too high, we go down here, get position, and we're at 910, greater than. So is it greater than 10 or 900? Yes, it's 910. So we're going to add 10 to it. Now, why are we adding here and subtracting here? Well, it's because my servo is upside down. If my servo was turned around, then we would have to swap this stuff. We'd have to change the too low to add, and we'd have to change the too high to subtract. So anyways, so we're still too high. We go over here, we add 10, we do that same over command, we move the servo to whatever it is, and we wait, then we swap, we drop, and we return. And also with the too high one, if the voltage is not too high, if it's below 900, so if we get here and it's below 900, it's 850, which is more than 750, but it's less than 900, this will just it will return that it's not true. It will skip down here. It will then click on go to, it'll go to skip, skips over this stuff, comes back out of the loop. So ideally, the way this works is once the voltage is above 750, it doesn't do anything. It doesn't try to increase it. And if it's below 900, it doesn't do anything. It just leaves the throttle exactly where it is. It's only when you put a load on it that the voltage is going to drop, and that's going to require increasing the throttle. And conversely, when the load is removed, the engine's going to start revving up and the voltage is going to go high, and so it needs to drop the speed to reduce the voltage. In mine, when this runs, it does it kind of slowly, but I would rather it do it slowly than quickly. Like I said, this is all just a proof of concept. If this was going to be on a real generator and running with real heavy loads, it would need to react a lot faster than this. And so basically, yeah, it just keeps doing this. It just, all it does is it just says, is it too low? Is it too high? Is it too low? Is it too high? Moves the throttle accordingly, and just keeps making sure that the button is on. Once the button is turned off, it goes back, moves the servo back to the idle position, and the machine will no longer react to loads. So of course you have to turn the load control. Either turn the load control off or remove your load before you do that. But that is the general gist of this program. I will put the code in the description of the video, and if it works for you, great. If it doesn't, I cannot provide any tech support. I recommend you go to the Pololu forums on their website and ask for help there, because I barely understand what's going on here. But anyways, that's it. It's working. Proof of concept successful. Thanks for watching.